In this video, we're going to do problem 2003, number 6, which is at the bottom of your Chapter 6 AP Review on page 25. So, it's pretty short. Now, working it out might take a while, but it's only 2 parts, and it says it gives you f prime is x times the square root of f of x. And then for all real numbers x, and then it gives you an initial condition. Okay, I would start to label, well, whatever, label that IC for initial condition. So then part A says find f double prime of 3. Okay, so I just feel like I can't get this right. It's like crooked or slanted. I think that's good. So if you notice they give you f prime, and we are looking for f double prime, so we need to take the derivative, right? So when we look at this and we're thinking we're going to take the derivative, well, you see you're multiplying two functions or two things in terms of x together. So that tells you that we should probably use product rule. And then when you look at this, when you think about how we're going to do the derivative of the second, anytime you have something inside a square root, if you're going to do the derivative, I would go ahead and rewrite that as that is what's inside the square root to the power of 1/2. Just because I know I'm about to do derivative, I went ahead and changed that. And now I can use product rule, and I'm going to need chain rule to do the derivative of the second. So f double prime will equal, now if we know product rule, it's the original second, so f, now if I'm not going to, you could keep the original second, either square root or use what we wrote here, times the derivative of the first, which would be 1, plus, and now you switch it, the original first, times the derivative of the second, which is where we need chain rule. So we bring the 1/2 to the front, keep the inside the same, which is f of x, to the power of subtract 1, which is subtracting 2 over 2, so negative 1/2. And then you got to do times the derivative of the inside, which the derivative of f is f prime. Okay, so just keep in mind, you're finding f double prime of 3. So if you're just looking for a value, you don't need to clean this up. Now you can clean up whatever helps you, but like trying to clean up over here and replace your f prime, which you could do, replace f prime with what it is, or you could just do it all with numbers, which I think is easier in this case. So I'm going to go ahead and change this to be f double prime of 3 and plug in 3. So I know times 1 I don't need, and then because I'm going to be evaluating a number, I'm going to change that 1/2 back to square root of f of 3. That's my first term, plus, now over here, I know I'm going to plug in 3 for x, maybe I'll keep everything for now, times 1/2. Now notice I didn't change this back to square root because it's negative, so I'm going to have to take care of that. So I'm just going to change it to f of 3 first, times f prime of 3. So maybe I should have done this before I changed the 3's, but it doesn't matter. So what do I do with this negative? I know it's going to go to the bottom, right? So when I bring it to the bottom, what is on top then? And you could keep these all separate if you wanted, or because it's all multiplication, it's like one term. So you can rewrite this as the 3 times the f prime of 3 goes on top, over, now this 2 from the 1/2, and this f of 3 to the, now it's going to be to the positive 1/2 because I moved it to the bottom. There are different ways you could do this. So if you worked it out separate, hopefully you did first. I'm hoping you're not going and changing it, because you could have kept all these separate and just made this 1 over 2 times f to the 1/2. And then we have the square root of f of 3 plus 3 times f prime of 3. And I'm going to change this back to square root now that it's positive 1/2. 2 times, oops, I forgot it, square root of f of 3. Notice the 2 is not in the square root. Okay, so now let's see. Do we know what f of 3 is? Well, that was our initial condition 25. Now, what else do we need to know is f prime of 3, right, for the top here. So we're just going to use our f prime equation. That's going to be 3 times the square root of f of 3. And now we know f of 3 is 25, so 3 times the square root of 25, which would be 3 times 5, so it's 15. So now we can replace f of 3 with 25 and f prime with 15. So that's going to be the square root of 25 plus 3 times 15 divided by 2 times the square root of 25. So that becomes 5 plus, what, 45 over 2 times 5. And that would be 5 plus 45 over 10. And honestly, you could probably leave your answer there. Or if we wanted to get this as one number, we could simplify this fraction or keep it. I think it's going to be easier if we simplify before we get a common denominator and divide this by 5 on the top and bottom. So that becomes 9 over 2. Correct? Yes. And now we could get a common denominator. So I'm going to put my 5 over 1. So then I'm going to multiply this by 2 on the top and bottom. So that's 10 over 2 plus 9 over 2, which is 19 over 2. Okay, so part B says write an expression for y equals f of x by solving the differential equation with your initial condition. So this sounds exactly like what we practiced doing a separation of variables, right? Anytime you're solving for the original or solving the differential equation, that's separation of variables. So you're going to take your differential equation. First you got to separate your variables. So multiply by your dx and you get dy equals x square root of y dx. So then we got to divide by our square root of y. So I'm going to rewrite this as 1 over square root of y dy equals x dx. So we separated, so now we're ready to integrate. So how do we integrate 1 over square root of y? That is not natural log. Why is that not natural log? Because your exponent on the bottom is not 1. What is your exponent on the bottom? 1/2. If your exponent on the bottom is anything other than 1, and it's especially if it's only one term, you bring it to the top and use power rule. It is not natural log. So we rewrite this as the integral is y to the power of negative 1/2. Now we are ready to integrate, right? So we're going to add 1. So that's adding 2 over 2. So negative 1/2 plus 2 over 2 would be positive 1/2. And you divide the coefficient. So you can make it 1 over 1/2, keep, change, flip, or it's just going to be the reciprocal of that fraction. So it's going to be 2y to the 1/2. But if you need to go over to the side and do 1 over 1/2, do that math. And then it equals, on this side, the integral of x would be 1/2 x squared. Yes, x squared plus c. Okay, so here's where we solve for y. We have our c now because we integrated each side. And this is where I would go ahead and plug in my initial condition before I solve for y. I think it makes this problem a lot easier. And you get a matching answer as the free response answers on how they do it on the AP test. Not saying your answer won't be correct, but it's not going to match theirs. So my initial condition, be careful, I know this seems simple, but what's in parentheses is x, what it equals is y. So I'm going to plug this in. Now I'm going to change 1/2 to square root at the same time. So it's going to be 2 times the square root of 25 equals 1/2 times 3 squared plus c. So this is, square root of 25 is 5 times 2 is 10, times this is, 3 squared is 9, so that's 9 over 2, 9 times 1/2, plus c. So I'm going to subtract my 9/2 to get C alone. So I would actually want to get this as a number. I wouldn't want to leave C, because right now we know C equals 10 minus 9/2. But let's actually get a common denominator. So 10 is over 1, so multiply it by 2 on the top and bottom. So that becomes 20/2 minus 9/2, which 20 minus 9 is 11. So C is 11/2. So what do? We go back and replace our C after we integrated. So it's 2y to the 1/2. You could also use square root of y equals 1/2 x squared plus 11/2. And now we want to solve for y because we want the solution y equals. So your first step is you would divide by 2. So on this, another way, if you divide by 2, and if you left your answer like this, it would be wrong. But if I write it like that, and that's just messy. Again, if you left it like that, I think you would still get credit. But a better way to write that would be taking the numerator, and the same thing as dividing by 2 is multiplying by 1/2, right? These two things are equivalent. So then I can distribute my 1/2, and that is 1/4 x squared plus 11/4. And lastly, how do I get y alone? Think about this. This might help if you think about it as square root of y, right? So if it was square root of y, how would you get y alone? Is you would square it, right? And that means you got to square this whole side. So then the square root and the square cancel, so you're left with y equals, now be careful because technically when you square this side, wait, no, I'm thinking of another problem. When you square, it's not plus or minus. Never mind. It's just all the inside squared. And that would be your answer. Which took us right to the end of the page. And that is that for your response.